this guy here, and then we'll do.
Sir,
yes.
if we're at the academy, do we need to do something different to pick up the kids, or are they going to be in our mailbox?
I think it's going to appear sort of like Santa Claus. I'm not sure. We're going to figure that out. I thought you had them already, and you don't, so I will square that away, and we'll make sure you get them. They should be, if you're off campus, they should be coming with your textbooks. If you ordered textbooks, which you should have. And then if they're on campus, I'm sure there's a mechanism to distribute them. Again, we won't be using them in class until 6 weeks, although I'd like to get them in your hands earlier if you are curious and want to play with it. Anyway, just one little extra hurdle that we'll have to deal with, but we'll get you some hardware so you can really start building stuff. All right, so I guess we'll just go ahead and get started with the lecture content. Maybe 1 minute before we do that, let's make sure you guys are all here. Okay, so I'll share my desktop, and I want to make sure you all are in the. It looks like everyone was able to register for the Google Classroom. Let me rearrange my desktop for a moment here. Give me 2 seconds. All right. All right, you're able to see that this is the Google Classroom. And hopefully you have some familiarity. If you did summer school with a class that used Google Classroom, I'm going to organize this. The stream tab, I don't know what that's about, but I suppose it's all the latest and greatest. If you go to classwork here, that's more under my control. Course admin is going to be the top here. That's where we'll keep the syllabus and the course policy. I would encourage you to keep track of the syllabus as things go forward. No doubt we'll have to adjust. And so this is a bit of a living document. The Zoom link to join the class will be up here as well. So this is kind of pinned to the top. Then I'm going to break it down into lectures, homework, and labs. So you've already got one homework here. That's just to install. Oh, look at 5 people turned it in. It's easy to turn in. You can just click turn in. There's nothing to do here. But we do want you to have that installed, hopefully by tomorrow, so that for the lab we can start to play around with it. Under lectures, you'll see I will post the material as a PDF. That'll be the lecture slides, and then after class is complete, I will also post a recording of our class. So that way, if you've missed something or the internet goes in and out, you have to run to the head. Don't worry, you can come back and play it through. They'll be posted on an unlisted link to YouTube. I mean, if you think they're awesome, feel free to share it. It's not for privacy concerns, but I think YouTube's nice because you can adjust the playback speed and all those other fun features, so you can see me talk like a rabid squirrel. So keep track of that, and this will be where we'll put everything. So homeworks will be submitted through this site and everything else. Any problems with getting on the classroom? Okay. It looks like you're all here. I have to count that. 14. Oh no, I guess we're short 1. So one of you isn't quite there yet. Figure that out. I will go through this later, and if it's you, I'll reach out. But try to get out there by the end of the day. Okay, so let me transition then, and let's look at the slides. So if you want to open up Lecture 1 yourself as a PDF, then go ahead, or just keep Zoom open. I'll switch the screen over to that now. All right, so once I'm in the presentation here, I don't actually see your wonderful faces or your chat. So please don't rely on the chat to send me anything. Just unmute yourself and say your question. I guess, class leader, can you see the PowerPoint slides? Does it look good to you?
Yes, sir.
Very good. Okay. And I guess I should get an updated footer here. It doesn't have Hopper Hall, which is, of course, our magnificent new home if we ever get there. But welcome to 200. So here's kind of the outline of this lecture here. We kind of inverted. We talked about Google Classroom first, but I'll tell you a bit about myself, how we're going to do this remote learning thing, talk about the course syllabus, the policies, kind of the bureaucracy of the whole thing, and some textbooks and software. Hopefully, at the end of this, we'll actually get into a bit of content. Okay, so like I said, my name's Dr. Donald. I got my undergraduate degree in electrical engineering at Princeton. And while I was there, I was an Army ROTC. So when I graduated, I was a platoon leader down in Fort Bragg, North Carolina. And then I deployed to Iraq for a year where I was director of network plans and operations. So we built and designed new large-scale networks for the computer systems there. And then got out of the Army, grew out my long hippie hair, and went up to MIT, got my master's and PhD in electrical engineering. And while I was there, a lot of my research efforts focused on diagnostics for very large machines and also some work on microgrids. And it turns out some of the largest machines and some of the most complex electrical microgrids are U.S. Navy ships. And so I ended up going underway on several Navy ships and getting very involved with naval research. And so it just seemed natural to come down here in beautiful Annapolis, where I'm deep undercover rooting for Army in my basement on the years that we do have Army-Navy games. Hopefully that's this year. Yeah, so that's my background. I've been here since MIT, and I am now an assistant professor. So when I'm not teaching in the class, then I have an active research program here. This is just a few snapshots of some of the projects I've been working on. On the left is the Gilliland, which is a huge, basically floating parking garage to deploy a U.S. Army, like basically division of vehicles and support infrastructure. So that ramp on the back can come down and you can drive on it. It's a massive ship. And our goal is to put some sensors, just a couple right on the main power systems, right, where the ship generators, and measuring the electricity, be able to tell you everything that's happening on the ship. And the goal is to be able to tell you if particular systems are operational, whether they need maintenance. So everything from fans to compressors to seawater pumps, those are all electrical, and if they start to malfunction, that it manifests itself in different kinds of electrical signatures. And so just by installing a few sensors, we can actually monitor this massive ship. Similar story, this is in the middle here is a Coast Guard cutter stationed in Boston Harbor. That's a Coast Guard officer and a couple of graduate students who I co-advise out of MIT. And this is actually a drug intercept vessel that goes off South America and, keeps all the waters safe. So they similar story, a few sensors to monitor all these complex engine systems. Then for closer to home on the right, there's YP 708. If you find yourself on a YP this semester and it happens to be the 708, you can see our 3D printer on board. So that's a system I designed with NavC. And we're looking at sort of the long-term environmental effects of doing 3D printing in an at-sea environment. The goal is to build repair parts or pieces on demand rather than relying on kind of the long resupply chain that they currently use. And when in a normal year, that would be my office. That's Maury. Now we're in Hopper, but currently all that equipment now is in my home office, my basement. I'll show you around in a moment. So always excited to build some hardware and to work on new projects. If you are interested in any of these projects or in other research activities in the department, please don't hesitate to reach out. There's always opportunities to get involved, and especially as you move forward in the major, be thinking about capstone projects, advisors for that, and I would encourage you to always ask your professors, hey, what are you doing outside of class? When you're not lecturing here, what activities you're involved in. I think you'll find all sorts of interesting activities. Okay, so enough about me here. Well, I guess this is one more slide about me. So how are we doing remote learning? This is based on guidance we received from the administration. We want your videos on as long as the bandwidth allows that. If we do come across, network bandwidth constraints, maybe start turning off the videos. But that just allows us to kind of get a bit more personal. And then the microphones, I'm happy either way. Right now, as everyone's in their rooms, probably microphone off is the best way to go. But if you're in a quiet area, no problem having your microphone on. And of course, as I mentioned, I won't be monitoring the chat. Please go ahead and just voice your concerns or questions as you have them. Don't worry about interrupting or waiting for me to take a breath. Sometimes I just don't breathe. I just keep talking. So make sure you ask. I'm gonna record all these classes, and like I said, I'll post them to the Google Classroom. So if I do talk too fast or you miss a class, don't hesitate to go there and watch them again. And we'll be using Google Classroom. So yeah, I've got my share of remote learning issues here. This is my setup from the spring. And you can see we got a professional Amazon Prime box as a desk and 3 kids around 1 laptop. I don't know if any learning is actually going on there. But I just appreciate your flexibility on my end and vice versa. If there's anything I can do to make your learning experience better, please let me know. And from time to time, I'm sure I'll be missing class or coming in with a noisy background, and I appreciate your understanding. So I think a dialogue and open lines of communication is the most important thing here. Just let me know what we can do to make this as good as we can, and hopefully that'll be all right. All right, questions so far? Maybe one question just to make sure that someone out there, at least one of you, is online and has an active microphone. Ooh. This is awkward. Class leader, are we there?
Yes, sir.
Can you tell if your peers are? All right. Well, we'll drive on then. Okay. So, course policy here. This document is on the drive or the Google Classroom, and I encourage you to take a look at it. I from experience, I can't see you now, but I'm sure when I start going over this, all the eyes start to wander until I get to the grading, and then everyone focuses, and then everyone drifts again. So I've just extracted the grades here. This is how we're going to drive forward with the course. You can see the breakdown. I just use an Excel sheet. You can do it too. I will strive to get all of your assignments back in a timely manner, usually within a week. So you should be able to anytime know your grade just as well as I do. Professionalism is just the expectation that you're, doing the right thing in class, looking appropriate. I expect that to basically be a freebie there. But it is there in case we do have problems. We take it seriously. Make sure you show up in your correct uniform for the day, that you're well-groomed, etc. All right, so homework late policy, 10% per day. And I will be posting the solutions about 1 week after we do the the assignments submitted. So after that point, it'd be a 0. So homework's gonna be graded primarily based on completion. And with the first homework assignments, I'll go over that more in detail. So once you get your first homework, we'll talk how that's graded and submitted. We will be having quizzes from time to time, and you should expect a quiz on Fridays. There will be weeks when we don't have a quiz, just we don't cover any new material that warrants it, but the expectation is that there will be a quiz every Friday. Basically, the homework will be graded on completion and submitted on Wednesdays. I'll ask for questions. Is there anything you didn't understand in the homework? And that's your chance to say, hey, I did all the homework. I ran through it, but I don't think I got any of the answers right. And that's fine. I'll give you 100% of the homework there. As long as you make a solid effort, right? Don't draw a penguin or some goofy joke. Really put some effort into it. And if it's wrong, though, that's fine. Then Wednesday will be your chance to ask questions and to clarify that homework assignment, so that on Friday, when I give you maybe one of the homework problems again or something very similar as your quiz, then you'll be able to really show me that you've mastered the material, right? So the homework is not meant to be a stressful experience. It's meant to be a way to kind of assess your own understanding and for me to see where everyone's at. And then the quizzes are really be doing the grading on that idea. So the quizzes will follow the homework closely. I guess I did get into it. We'll cover that again once we actually start having some assignments. All right, so 2 exams, 6 weeks and 12 weeks. Those will be 25% total, evenly distributed. The final exam is 25%. We'll be having a lot of labs in this class, as well as a final project. They will generally be weighted to how many weeks we worked on them. So some labs will just be 1 week, some labs will be 2 weeks, the project might be 3 or 4 weeks, and they will be weighted accordingly. Okay, questions on the course policy? Okay. Collaboration. This is always an important thing, especially in the engineering and technical courses. We really encourage you to work together, and I realize that in the current environment that's easier said than done, but we see it as a team sport. Working in groups of however many you find practical would be great. Please, when you do that, write your names at the top of each other's homeworks. Or you don't have to write your name at the top of someone else's, but put the names up. Say, hey, I worked with Greg, and then I would look at Greg's and he'd say, oh yes, and I worked with Sam, and that way I know that Sam and Greg worked together. It should not be that Greg came in and gave the answers to everyone, so everyone's homework has Greg on top, right? It should be reciprocal. If there's ever any question about what constitutes, copying versus collaboration, don't hesitate to reach out. I'm more than happy to clarify any questions. But by and large, I would expect and encourage you to work together on everything that is done outside of class. Now, in class, that's will be our exams and the quizzes. That's all individual. Given the current environment, all of the quizzes and exams are going to be open resources. That way there won't be any temptation to, or suspicion someone else was tempted, right, to Google something. We'll design the exam such that, none of the answers are particularly Googleable. And you'll be able to use the course textbooks, an internet, any saved assignments you have, that'll be fine. But you may not, for example, host a Google Meet with your friends or post a question to some forum. And again, finally, if you have any concerns about any of this, ask before you act. Right? It's always easier to deal with this before it happens than to go back and have some problem here. Any questions on collaboration? All right. Yeah, good. It's pretty straightforward. So there you go. Google Classroom, this was, we talked about this in the beginning. Everything's going to be up there. One thing to note, I think it's particularly helpful to add the course calendar to your calendar, and that way you can see our meeting times, any assignments when they're due, and I've also put the Zoom link into all of the events, so that way you can just click on them and join. Okay, yeah, and the syllabus, let's see, is that going to come up? I think we'll have the syllabus in a little bit. All right, so textbooks, I would encourage you to purchase both of these. I know it's been going around, hey, there's an online copy of this or that. I'm, not interested in hearing about it. I'm not going to check your books. I'm not going to validate one way or the other. They're there for you to learn how you do best. Don't do anything unbecoming of an officer and get yourself in any hot water. So if that doesn't make sense to you, don't worry about it. There's already been some concerns with sharing book codes, but yeah, these are great resources. But in general, C and MATLAB are taught all over the place, in all manner of techniques. And if there's a book that speaks to you or a set of tools online that you like to learn from, by all means use them. Our homeworks and the lab assignments will not be coming from these books. They will be generated by ourselves and some of the MathWorks labs themselves. So use these books, buy them. They're inexpensive. We design, we pick these specifically because they're inexpensive, and also at the level that they're very readable, right? So I highly recommend them, but I'm not going to be doing like book checks or anything like that. All right, let's see. I guess so we'll that's kind of the end of the course overview here. After this, we'll drop into a little bit of content today and kind of talk about the course structure. I will say, just in broad brushstrokes, our syllabus is a living document where we're changing it weekly, even daily sometimes, based on resources that are available to you, the ability to have hybrid labs and such things. So please, if you're particularly interested in a day or time what we're going to be learning, check that syllabus often, and it will continue to be updated. The expectation right now is that we'll spend the first 6 weeks learning MATLAB, and then we'll switch. The next 6 weeks we'll do C, and then at the end we'll do a project which combines both of the languages together. There will be labs, software, probably only labs for MATLAB, and then in C we'll actually be using hardware. All right. So this class is really, I've had to boil it down into a single sentence. It's how to program, and we don't, and how to program for this major. I would say it's not a computer science class. Like, we're not going to be talking about programming as an art or the mathematics of computer programs. This is computer programming as a tool, right? Imagine that you're going down Home Depot and you want to build a house, and you're going to buy a saw, and you're going to buy a drill and all these other pieces. This is where you learn how to use a saw and how to use a drill. We're not going to talk about how to build the best drill or how to design the blade of a saw. We're just say, hey, this is what you need to know in order to succeed on these tasks. So at that level, it's very applied. And I think that appeals to a lot of students, right, who might be turned off by kind of the theoretical nature of programming. So this is programming with applications. And we do not in any way expect you to have programmed before. If you have programmed before, that's great and good. But if this is the first time you're seeing the letter C associated with programming or anything else related to code, that's great too. So we're going to be starting from scratch and working from there. If you have experience with a language and would like to try to learn more about it or want to work deeper on any of these problems as well, don't hesitate to reach out to me either. I am happy to. Some of the topics we'll cover quite quickly in this class, just because we don't use them very much. But if you want to explore them in any more depth, I'd be happy to talk in EI, for example. All right, so that's a kind of a long-winded introduction. Any questions on the course policy, course structure, expectations, etc.?
I have a quick question.
Right.
Are most of the grades returned through Google Classroom, or will they be on Blackboard as well?
That's a good. I expect to only be using Google Classroom. Yeah, if there's a strong preference, like there's a reason why you'd like to see them on Blackboard. This is new to me. I usually have paper and I hand it back, and that's how we do it. So I don't have a pre-existing kind of conviction for one platform versus the other. But my expectation right now is that we'll just be using Google Classroom. And I don't expect to use like any kind of fancy grade book structure with it either. I don't quite understand how that works, and I don't know that I'm going to do all that. But for all of your assignments, you will get a numeric feedback from me on like, hey, that was a 10 out of 10, or that was a whatever.
Thank you.
All right, good question. Okay, so the next set of slides here is kind of at a high level. Like, so what have you gotten yourself into? Beyond EW200, what is robotics and control all about? All right, so it's probably one of the broadest disciplines in the engineering department. And if we had to really break it down into three parts, I would say you've got autonomy. How do we get things to go by themselves? And that's robots, that's autonomous vehicles, and of course that closely relates to weapon systems, and all the way down to like smart thermostats, right? So things that can kind of do things by themselves. We work closely with the sort of primary engineering disciplines: electrical, mechanical, ocean, right, aero, and computer engineering. So we'll generally take the end results from their disciplines and combine them into a complex system. So oftentimes we'll look at double E's, electrical engineers, and say, hey, what's the best sensor for this application? And we'll just accept it as is. Say, hey, I don't exactly, I'm concerned about how this camera measures like light intensity, but what I want to know is light intensity. So give me that box, and with the 5 wires that come out of it, and then we'll go to the mechanical team, mechanical engineering department, and say, what we really need is a motor that can produce a, high speed and, a certain amount of torque, right, like power basically. And, does that mean I need gears? I don't know. You can tell me what the best way to build this motor is, but here's the motor. And then from the computer engineering side, I need a processor, some kind of computational device that can run my algorithm, right? That can decide, kind of take a program and execute it. And so with these pieces, then we can put them all together. I can get a computer, like some kind of microprocessor, to connect to the sensor and to the motor, and then I can write a computer program, which we'll learn how to do in 200, to actually do something intelligent, right? Like make a robot that follows the brightest light in the room. And our value is in the ability to glue these components together. And then a very important part, and these are all kind of coupled together. I don't mean to make it sound like there's 3 different kind of tracks here, but broadly speaking, control and sensing is classically found in electrical engineering departments, but is totally in the domain of robotics control at the Naval Academy. So things like image processing, modeling, sensor fusion, all that, it will be taught in courses at the 300 level here. That is going to be kind of like, today in this semester, we'll learn, how to be dangerous, right? with microcontrollers and code. And like, we'll give you sensors, we'll give you motors, and you're going to make that robot run. And that robot's going to run right into a wall, right? And just fall apart. But hey, you did it, right? That you got the wheels to spin and you got the sensors to return some information. The next year, the 300 series class is going to teach you how to do things better, right? How can you use multiple sensors, combine their outputs, and get a better estimate of reality? How can we write code that's robust in terms of environmental disturbances? And then not only will the robot move, it will move well. And then in your first class year, through your capstone project, you'll take your ability to build things, which you'll learn this year, to do them well, which you'll learn next year, and then actually put it all together on a project of your choosing, right? And you'll say, hey, what I've been waiting for this whole time is to make a weather balloon that I can send up and take air quality readings, or I want to make a system that can throw bubbly beverages across the room to my friends on a futon. You can kind of pick these pieces and apply what you've learned in a format that's exciting to you. So that's kind of the major in a nutshell. Any questions? Hopefully this sounds exciting for those of you that are still here. Good. I'm glad. Hey, I'm excited. You're excited. This is good. All right. All right. I'm gonna show this, and this is what they call like spiral teaching, right? You'll see it once, and you'll say that was weird, and you'll see it again. You go, man, he really likes that graphic, and you'll see it again and again. And eventually, this will really be, part of your core thought process here. So this is going to be a graphic and a diagram and a thought process that you'll see in every class you take in this department. And that's the idea of a control system. So let me just talk through this quickly here. Again, I don't expect it to all sink in, but we'll come back to it again and again. And it's kind of like, how do we think about building a complex autonomous system like a robot or a guided missile or a smart thermostat? All right, so in general, you're going to have something you'd like to control. And let's just... to make it concrete, say what I really like is for a car to be able to drive at a particular speed regardless of the terrain. If I'm going up a bunch of hills, I got to apply more power, but if I'm going down hills, I don't want to apply as much power, but I want to keep it at 60 miles an hour. And of course, you've seen this is like cruise control, right? So how does a cruise control system work? Well, you're going to have something like the actual system itself. So this would be the engine, right? And this isn't under your control. You got this from the mechanical engineers, and it is what it is. It's a car. And the input to this system is maybe the gas pedal, right? And so that would normally come from a human, but I want to change it so that it comes from some kind of automated system. All right, now the output is going to be the car moving forward, some velocity, miles per hour, right? And so this is reality over here. The output of the system is the fact that the car is moving forward. I'm going to measure the reality using a sensor, okay? In the case of cruise control, that sensor would be a speedometer. And that is going to provide me information about the real world. Okay, so notice these arrows have direction to them. The input to my car, right, is a is a acceleration signal from the gas pedal, right? And the output is a speed, miles per hour, and I can measure that as an input to this sensor. Now the sensor, okay, is going to produce a reading, right? Say, yes, you're going 30 miles an hour. Maybe that's what the sensor produces based on its measurement of the wheel speed. So to make this system autonomous, what I'm going to take the human out and replace the human with this block I'm going to call a controller. Okay, and that's going to be my computer program. We're going to learn how to write this block this year. Okay, and you're going to get better at writing these blocks next year. This block right now is going to be pretty simple, and it's going to get more and more complex. But the bulk of your time in the engineering weapons department is going to be working in this block here, right? This came from the mechanical engineers. This is generally the realm of electrical engineering, and you're going to be right here, writing this controller. Okay, so how does this work? Well, say a human, now here the human sits out here. We've moved the human. They say here, I'd like to go 60 miles an hour. Okay, so that command 60, all right, goes into this box, which compares it. It says, hey, you're currently going 30. You'd like to go 60, right? So we've got some problem, right? You're not going fast enough. The controller will increase the signal to the engine, and you'll start to go faster. Then the sensor will go, oh, we're getting faster. We're getting fast. Now we're at 60. Then we don't have any problems. The controller says, all right, just coast until we start going too slow, and then we pick it up again. So it's this loop. It's this idea that we're producing something and we're measuring what was produced and using it, feeding it back, okay, along with our command into this controller. So again, I don't expect all of that to instantly make sense. In fact, I hope it doesn't, because if it does, then you won't have to take this class and I have nothing to teach you. But keep this in mind. Your role, your home is in this controller box, and you'll be learning how to interface with motors and physical systems. You'll be learning how to read from sensors and process data. All right, so what does that actually look like? So here are some projects from previous years in 200. Now, this year is unique. We'll hopefully have these same labs, maybe out of order. But here in the lower right is a MATLAB video game. That's going to be your production. Right around 6 weeks, we'll start that project. And so you're going to use your knowledge of MATLAB to actually make a video game something like Mario or Flappy Bird or one of these retro classics. Then we're going to give you actual physical hardware, right? Hopefully you'll get those kits that I mentioned earlier in the class, and you'll actually be able to build something. In our classic project for that, we just call it Build Something Cool, and we give you a bunch of sensors and motors and let you go to it. And so this was a crab race game here. We've had little shooters, trucks, and pinball machines, you name it. It's kind of a fun opportunity just to be creative. And a big part of this class, beyond the technical, is in the group dynamics on how do you work with a team of engineers on a project that is more than something you just do by yourself in a single day. And that's hard. And it's a soft skill as much as it is a science. And so hopefully we'll get that opportunity to have you work together and collaborate on projects. These top corner pictures are what are typically used for our first lab, which is build a Lego cart that can go down a ramp and crash into something. But we'll have fun still. And again, the goal is to build physical hardware. This is normally done in C. Build a video game in MATLAB, and then actually have your video game control hardware in the end. And so that's what this lower left-hand corner is a physical scoreboard that actually twists and rotates as you get more points to indicate where you're at in the game. All right, so and then I think this is hopefully right about the last slide here. This is just your matrix. I hope that you've seen this with your advisors. If you haven't, you should ask your advisor to see your matrix. You can see it in mids. I think this is just a nice graphic to show you how these classes fit together, especially now that you're in a major, right? So here you are in third class in 200. This is really, two classes that work closely together, 200 and 202. And you may, or may not, depending on your opinion, be fortunate enough to have me in 202. I teach both. And most instructors do. We try to keep that continuity. And so here's we'll learn how to do software, right? Mostly programming, and in here in 202 we'll do more with hardware, and that works well with the current remote situation as well. I'd like to also point out, in the far right corner here, once you're first class, then you've got this, your opportunity to really define what WRC means to you. We have one of the broadest groups of major electives in any of the engineering departments, and which is a blessing and a curse. There is a lot to choose from, and so you can really find things that are right up your alley, but you've got to go out and learn about them. We do provide you information in second class here, kind of a bunch of slides, but nothing that compares to you going out and talking to your classmates in your company. If there's a professor you like in particular, say, hey, do you teach an elective? What was that about? If you're proactive, I think you'll find yourself in electives that suit you better than if you just wait till the last minute and go, oh, I heard, mobile robots is cool, and then you come to find out like it's not what you want. So please be proactive. Think about it. We'll be providing information to you, and I know it sounds like it's a ways off, but it'll come before you realize. And if you are particularly interested in some topic, you don't necessarily have to wait until you are first class to explore these. We always have the ability for you to add like kind of 1 credit hour courses or just work outside of the classroom on a particular project of interest. And I'm happy to coordinate if you tell me your topic that you like to do something with. I bet we have a faculty member who is working in that area. So if that rings a bell with you or resonates with you, then please don't hesitate to reach out and get you set up. Whew, okay, so I think this just reiterates again with a few more graphics, right? But the idea that we're really at the synthesis of several engineering disciplines, right? And I think that's an exciting spot to be. We really get to see the end result of the best sensors, the best actuators and mechanisms, and the state-of-the-art programming, and we put it all together and build pretty awesome systems. So these are just some of the examples that in the popular literature out there. And again, I wish we were in Hopper and could show you some of these things in person, but we'll be there soon enough. Okay, so that's all I've got for this particular lecture here. Any questions? Not everybody at once here, I give everyone a chance.
So what other classes do you teach?
Sorry, 1 second here. I teach, did we not get this? Oh, no, I've got way too much technology here. Wait for it. It's coming. There it is. I teach 200 and 202, this course sequence, and then also 430 and 432, which are senior electives, first class electives in, it's called embedded systems. It's really building stuff, right? So in the the fall semester, you get a kit, literally a briefcase full of transistors and buttons, and we learn how to build computers from the ground up, and the end result is you have an alarm clock, which sounds humble, but it will take you the whole semester, and how to figure out how to use keypads, batteries, program assembly language. And then in the spring, we move up a level into Linux and Python, and how the internet works. You build a website where you can post messages and get likes, and then the goal at the end is that you can then actually have your alarm clock show the most popular messages. So it actually connects to the internet and tracks your website. And so that's kind of the Internet of Things piece. And so the whole course, while it is 2 distinct semesters, it kind of flows together. So there you go. Yeah, good question. Any other questions? Okay. Let's see. We've got about 10 minutes left here. I'll show you just, we're supposed to, kind of show you a real person here. I guess this is my my basement setup. So you've got my lab bench working with any kind of hardware we've got going on, and my recreational area. So this is my COVID hideout. From time to time, you may see my children run through. I've got 3 of them, and they're awesome and very loud, very small. So appreciate your flexibility there. And yeah, so let's see. I guess let me spend like 8 minutes here. Any other questions? This is your chance.
So from last year, those projects where you got to like build that pinball machine and stuff like that.
Right.
How's that gonna work for this semester if we're like distanced?
I'm just gonna send you out to the scrapyard. You're gonna get some metal. You're gonna send some acetylene torches. Yeah, I certainly hope that there's a point when we can have you work in small groups, or we've got plenty of kits, not necessarily one to a person, but we'll see. I mean, that was the effort when we purchased all of these sensor kits. That's never, in previous years, you've never been able to take the stuff home and work on it. So we ended up getting everyone their own kit. And so I think we'll just have to adjust. Maybe a pinball machine isn't quite the thing this year, but maybe like a automatic, plant tender would be something cool, right? Something to measure the soil, pH level and let you know when your plant needs some care. So we'll see. But I'm confident that we'll be able to get some hardware going on, and that you'll be able to get creative with it.
Sir, I had a question.
Great.
I know that the department has some 3D printers.
Yeah.
So does it also have like CAD software licenses available for us, or do we need to design our things with department computers?
Good question. Good question. Yeah, so we have access, and you have access to a wide variety of manufacturing equipment. And I'll tell you, on my desk here, I've got a CNC mill that can print out circuit boards. And behind me in that door is a set of servers and a 3D printer that a Trident student, that's a first class research kind of opportunity you can get, controls from his dorm and is doing all sorts of telemetry on. So, and then when Hopper comes online, laser cutters, all manner of printers and machines are at your disposal. As far as the tools and expertise to control them, we have a variety of professional engineers and technicians. So they are there to help you. A lot of times for capstone, that if you come in with a plan and say, hey, I have never done a 3D print before, but this seems like something that we could work on, as long as you're willing to kind of work with them and learn, and not just be like, would it be great if you did my capstone? They will certainly assist you with that. And if right now you say, man, I need this cool widget to hold my phone, and I've designed it, we can help you print that. So I guess going in levels, right? So for core support, you can learn it in the class. You can learn it from the engineering technicians. If you wanted to go at it on your own, we don't have like USNA licensed like SolidWorks for your personal laptops. But I think that like Fusion 360, Google SketchUp, there's a lot of tools out there that come with educational licenses or just free. If you're curious on any particulars, I'm happy to point you at them. We do have SolidWorks licenses if you're on campus and on USNA machines. And that kind of is the state. For those of you that are kind of lost with all these jargon, that's kind of the state-of-the-art 3D modeling tool. Long answer to a short question, but does that give you information?
Yes, sir. Thank you.
Okay, great. Anything else?
Sir, how long have you been a professor at the Naval Academy?
This will be coming into my 5th year. I think that's right. Yeah, so I came with a PhD at MIT and then came straight here. I think that is moderately typical. Like, there's another set of education you get, like a postdoc. Sometimes you hear of people doing kind of research a few years before becoming a professor. But I came straight from graduating there. Yeah. So if you look at like the faculty, actually we just hired a new faculty member. He's teaching a 200 section VOA. But as far as seniority, I'm right above him. So if you're looking for like really, department history or long guidance, I'll probably not the person. But I know those people, so I'll get you in touch. Okay. Well, I don't think it's a crime to let you go like 4 minutes early on our first day. I hope your first e-learning day has been tolerable. Mine, I would say mine's been tolerable. If there's anything I can do to, make this better, please don't hesitate to email me or just yell it out in the middle of a Google Meets thing. And I look forward to talking tomorrow. Sound good? Okay. Well, carry on. Have a great day, and stay safe out there. Michael, they're all yours. I mean, you don't have to do anything, but class leaders, good job. All right.
sir.
Talk to you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Yep.
Thank you, President.